Good afternoon. Welcome to day 20 of projectDig. Thank you for joining. I hope you're having a good day so far. I'm having a pretty good day, except that allergies are pretty bad. So apologies if I sneeze or sniff a lot on stream. I'll try to mute the mic when I can. But yeah, besides that, going pretty good. I have some coffee here, so it's about to get much better. Yes, so we're going to be picking up where we left off yesterday, which is with data serialization. So that basically means to be taking all of the data in our game and writing it to some data stream, serializing it, which can then be written into files or sent across the network. And then, so that's writing, and then we need to also be able to read. So we worked on that yesterday, made some pretty good progress. We have these two different classes. We have a WriteStream and a ReadStream, and they do different things. A ReadStream is solely for reading through some data. So we can load up some information, and our ReadStream just points to that data. It says, okay, I'm reading at this point for this amount of length, and then you can pull out information and it will assert that you can actually read that and just give you whatever you're asking for. It does not do any checking, so I guess maybe I should go back or go over to the WriteStream. So the WriteStream is kind of the opposite, where instead of reading data, it's writing data. And so we're actually accumulating, we're like saying, okay, give me this information and that, and it's all putting it into this vector of bytes that we can then hand off to either the network or some file IO API, and it will write it to disk. So currently there's no solution in place here for ensuring that we are reading and writing the same data. Like, we're not saying, oh, it has to be a string and then uint32 and then int 16 or whatever. Like, it has no concept of that. We are currently responsible for ensuring that the order that we read and write the data is consistent. And that's something that we might look at a little bit more today. Something I've been kind of thinking about, but fortunately that's somewhat separate from this. That's like an addition to what we have done. So the read and write stream, that's just like serializing the information. Serializing and deserializing. And then there's that other feature on top of it, which would be some way to ensure that our data is being written. Written and then read in the same order so things don't get messed up. Because if you try to read an int 16 and then try to, if you try to write an int 16 and then a string, but then later you try to read a string and then, you try to write an int 16 and then a string, and then whenever you're reading that data, if you accidentally get those flipped around and you read the string first and then you read the int 16, it's going to be completely screwed up because it's expecting for it to first be an int 16, so the first 2 bytes would be an int 16, but instead we're reading the first 4 bytes as the length for the string, and so it's going to think that the string is a very different size than what we actually wrote, and so it might like, try to be reading out of our buffer, and hopefully that's like best case scenario, because then it's going to assert that, hey, you're trying to read too much. It's much worse whenever it's just silently is like reading in a bunch of garbage or whatever. Hey, Yonetta, what's up? Hello, hello. Hey, Swartz, what's up? Greetings. So, there's a few ways we can go about solving that. Hey, Arstat. Greetings. Hope you guys are having a good Saturday so far. Yeah, there's a few ways we can try to solve that. In the past, for Korea, my previous game, it wasn't really that much of a problem. So I don't know how much I will really worry about it. Something I'll be thinking about. Maybe we'll talk about it more later on stream. I honestly think that if we do things, mostly if we are diligent with writing our unit test, it should never be a problem. And the best way to do that is, I would say, like, always put all of the data that we are writing into a struct. Write a shift operators, left shift and right shift operators for writing and reading the data for that specific data structure, and then doing a unit test on that. And this unit test, like, okay, let's create this object, make a copy of it, or create this object, write it to a data stream, then let's create a read stream from the data, or from the write stream, and read that data into a new copy of that struct, and the two structs should have the same data. And if they do, then that means that we properly wrote and read our that chunk of data, and it's in the same order, and we're saving everything right, and yeah, all that stuff. So it's not too complicated. Unfortunately, like a lot of development, it's just made up of all these smaller parts, and so it's like, hey, if we test all these smaller parts, then as we put them together, we know that that bigger thing is going to work because we have all of the smaller parts set up. Can I distract you with a slightly unrelated question about your component pools? Slightly unrelated. I would say that's extremely unrelated. I'm just kidding. Yeah, go for it, man. Hit me. So, sorry, my nose is super stuffy from allergies. I took some medicine like 40 minutes ago. Hopefully it'll kick in and nose won't be so bad. So, what we're going to do today is write some tests for this. It shouldn't be too difficult. It's a really simple interface, which means writing tests will be easier. So yeah, we're going to write some unit tests for our read stream and write streams. And probably just do exactly what I was saying is, read some data, write some data, and make sure that it's the same. Yeah. So we'll start with that, and then we'll see where we're at afterwards. Okay, so this is going to be... So unfortunately, I don't know how well I could do... I think I might just like combine these into serialization, because I can't really individually test these. I mean, I kind of can, but it's so much easier if I test them together, right? I noticed while watching a past VOD, you had a regular component pool and an active component pool. I was wondering what the difference was. Yeah, sure. Yeah, in one of the VODs, I actually go over the active component pool. Let me find that for you. And so I think I actually call it active pool, right? Maybe, oh yeah, active components. There we go. Day 15. So I can explain it really quick, but if you want to see more about the development, you can check it out there. Yeah, by the way, if you guys don't know, I post all the VODs up on YouTube, so you're welcome to check them all out there. There's actually, I should probably make a, there is a playlist of all of the VODs. And also I finally put up a recap video. So just a really simple recap video. Yeah. So you're welcome to check that out as well. This is my first post on Patreon. Yay! I'll probably only post the recaps. What I'm thinking of doing for the future ones is including all the videos that I'm recapping. So if someone wants to like be able to look at more. But yeah, please give me feedback on the recap videos. It's much shorter. It's only 10 minutes instead of like, 7 hours like these other videos. But yeah, anyways, so to answer your question about the active component pool versus the normal component pools. So for those who don't know what a component pool is at all, component pool is a list of components. So a component is like transform or render or physics component. It's just a plain old data structure. And that is all of the components for the entire game, like all the entities are contained within a component pool. So this is for the ECS, our entity component system. So we keep all the components here in the m_components, and we keep this as a dense array, which means that what we do is we allocate a lot of data up front. We say, okay, let's have this, contain. Maybe there's a better way to do this. But yeah, we'll say let's have this vector contain 1,000 bits of memory or 1,000 components. So that way it's not having to allocate stuff and move things around. It just has that huge chunk of memory. If it needs to, it can expand, but we try to allocate a lot up front. And we might only have like 10 active. So sorry, I shouldn't say active. We might only have 10 components in use. And so all of the other like 900 components, 990 whatever, they are unused. So, and what we do is we keep all of the used components at the front of our component list, and any unused components are moved to the back. And so that way, whenever we're iterating over our components, we can just say, okay, let's go through all of our components. Oh, we have 10. We'll just do 10, and that is the components count. That's how many are currently being used. Active component pool adds on to this, which is how many components are currently active. So it's kind of like a state. So we have like this used concept, so it's used or unused, but we might have a used component that's inactive. Right now we have 2 examples of that. Maybe that's all we're ever going to have is 2. We have our physics component and our collision component. So the idea for that is we'll have our physics component that goes to sleep. You stop moving, it goes to sleep. We don't need to be updating that anymore. Like checking to see if it moved or whatever. We know it's not moving, it's sleeping. Unless something hits it, and then it wakes it up and it becomes active again. And so, yeah, if you are familiar with like physics stuff, it's basically sleeping or being awake, active. So, inactive is synonymous to sleeping, and the other example is with our collisions. So we can have a component or an entity, let's say a door, that has collision because it's closed. But whenever you open it, we want to disable that collision. And so we can just mark it as inactive. And so what it does, like behind the scenes, that our active component pool is keeping it. Now it's in our component list is active components, inactive components, which makes up all of our used components, and then after those are the unused components. Yeah, hopefully that makes sense. That's the difference between them. So if we look at our world, you'll see that we have our physics components and collision components using our active component pool. So this is a way to make it efficient. You could, like instead of doing this, you could remove the physics component and collision component. But for something like, especially a physics component, it's kind of a pain to do that, because then you like you could remove the physics component when it goes to sleep, and then whenever you wake it up, you add it back. But it's like, where is that physics component going while it's sleeping? Like, there's nothing else holding on to that pointer, and so it's kind of weird to do that. Or like, you wouldn't want to do that. You need to like store that state somewhere, or it's just completely lossless state. Like you don't care about it, and you throw it away, and whenever you create a new component, it's fine. I don't know if that would be okay. It seems like it would be very wasteful because you're doing this a lot, whereas with the move, all it's doing is the swapping some. So it shouldn't be too expensive. Like, I mean, I don't know how expensive it is exactly, but I imagine it's significantly less expensive to do that versus completely removing the physics component, which means that we have to go through and update a bunch of stuff, and also it's kind of weird because then it no longer has a physics component. Yeah, another way you could also do it is having a flag on the component that says it's active, and then whenever it goes to sleep, whenever you sleep a physics component, you set the active flag to false. Whenever you wake it, you set it to true. The thing that sucks about that is while they are waking and sleeping often, something will go to sleep for a long time, or it can, like something comes to rest, doesn't get moved. So like I imagine most of the time whenever physics stuff happens, it's like it's active, oh sleep, oh something's still touching it, it wakes back up, it goes back to sleep, and then it wakes back up, and then it goes to sleep, and then it just stays asleep for a long time. And so if you are using this a flag to check that, since we're trying to iterate over these physics components, hopefully we're doing that. But if you're iterating over them sequentially, then that means that we're going to be having cache misses whenever we hit. Well, kind of. It's wasteful because we're like, hey, give me this component. I want to. Oh, never mind. It's inactive. Give me the next one. Whereas if we are only iterating over all of the active components and we're keeping all the active components together, then we don't even have to look at the inactive components, and that's why I have them separate. So that's the benefit of not using a flag and instead having it just, store the data in a different way. And this is like a pretty common data-oriented design approach for dealing with things, is you don't want flags, because flags means that you're having this conditional check and you're having to branch stuff, and it also means oftentimes you're like loading up data that you might need or you might not, and so it's better to just say, hey, here's all the things that we're going to want to do together, and here's all the other things, like, like let's say you did want to iterate over all of the sleeping physics stuff. You could still do that. It's just like you would want to do that separately, and having them be in their own pools makes it easier. Yeah, but that's my understanding of it all. It makes sense. Obviously you have to look at how you're using the data and make sure that that makes sense, because maybe, like in our case, maybe we're not actually iterating over all the physics components sequentially, because, and this is something that we could probably optimize in places where like we're getting the physics components by the entity IDs, which means that we're doing a hash lookup, and then we're indexing into the physics components somewhere. And hopefully it will help some still, because whenever it fetches all the physics component stuff, it's going to get a huge chunk of, it might get several physics components and they'll all be together, and hopefully then whenever we query the next entity, it will be getting that next entity will be close to the previous one in the physics component pool. But yeah, you really have to just look at how you are using data. So maybe it's a premature optimization, but still kind of cool. Something to think about. But anyways, yeah, so glad that made sense. Yeah, you can watch the VOD about it. I think we spent several hours working on implementing that. Yeah. It's pretty cool that we have the VODs up where I'm like, oh yeah, this is exactly where you can go and look at it. Okay, so yeah, let's work on doing some unit testing. So what do we want to test? Good question. Wonder if there's anything that we want to set up. Yeah, I think the easiest way to do this is can write, read. I think just something like this. So it'd be, let's see here if this works. uint8 type value equals, let's say 42, and then what we want to do is get our read stream, our write stream. I don't think it has a constructor. And then we just say we want to write the value to it. And then what we need to do is now get our read stream. Maybe I'll call this writer, and our reader. Oh, and our reader needs the writer. I think it's get data. and writer get size, or no, it's size. And then our reader, I think I need to import the file so we can actually. We're gonna need the HPP for this one. So our reader, then what we want to do is maybe I'll say this is original. Or maybe I'll call this data. Yeah. Read out our data, and then what we should require is that our value is equal to our data, right? Is the size of mpool and mcomponent the same? Is it possible to combine cycles? Is the size of mpool and mcomponent the same? What's mpool? Are you talking about this right here in our world? Oh, these right here. No, they're not going to be the same. Pools are for our entity components, and then m_component is for our world or singleton components. Singleton components are, that's basically how we share data and state for yeah, how we have state and share state between our systems. So instead of saying like, hey system, I want to get access to your spatial hash, we store the spatial hash in this like entity spatial component, and that can then be accessed by whomever, and our systems are completely stateless. It's pretty cool, actually. Oh, whoops. We screwed that up, huh? I wonder why it was all wonky. ReadStream is undefined. ReadStream is undefined. Should be able to find it. I don't think that's supposed to be there. Wait. T. Oh, I see what happened. I missed. Oh, whoops. T. Did I mess up the rectangle as well? May have. Oh, I just didn't do it. So this needs to be rectangle. Okay, how is this now? Spec is not a valid template argument for parameter t. Okay. That sucks. Maybe I can't do it like that. I thought I could. Maybe I have to do this outside? we'll try this. Types. There we go. Let's just see if this will work where we put this down. Let's put it right here. And we'll say vector. Seems like that works. That's too bad. I was hoping we could just do it like that. Oh well, it's not that big of a deal. Do not include utility, ReadStream. Sounds like I did not put that in the right place. ReadStream, utility, ReadStream.h. No, it's in there. ReadStream. Siege utility ReadStream.h. Can't find that. That's what it's saying, right? No set file or directory. Is it because this needs to be siege? Traits is in here too. I think the problem is that really, I think I probably should just say that this includes that directory. Which is siege. I think that's my problem. I did not have the include right. Okay, cool. Oh, whoops. It looks like we forgot to do one thing here, which is change this to be bytes. So let's do that. We got rid of some things in here. Wait, what? Did this not save? Oh, it thinks that we're in data stream still. What the heck? I deleted that file, no? Hold up. We should not. Okay, I don't know why I was doing that. I deleted that file. I don't know what was going on there. It's not byte. What was it? Maybe I didn't have to include anything. Okay, I think that's what we needed. And then this takes a byte. This returns a byte. This returns byte. That's fine. That's fine. Cool. Okay. I think that's it. Aha. And then in here we need to say this is our assert util. Cool. Yay. So let's see if it passes this. Yay. Success. That's good. That's good. It means that we can run it again and we can see it breaks. Yeah, I really like writing these unit tests. Like, I didn't write them for Korea at all, but man, it's so nice having like confidence in the code. And also not just confidence in the code, but like being able to confidently change. So there's our data. Nice. It's awesome. Yeah, just being able to confidently change the code and know that if I broke something, most likely it's going to be caught through these unit tests. It's empowering. Okay, so let's write a bunch of unit tests. I wonder if we could trim this down some. I guess one thing we could do is always have the writer up here. Oh, does this need to, okay, there we go. So then we don't have to make the writer every time. It's the only thing I can see that we can actually do with this, unfortunately. Yeah. Maybe we'll actually do an int 8. Try having it be signed. We have a uint 8, and then we can do, oh, uint 16. We can do it int 16. Yeah. So we have all these primitive types. We can also do 32 to say, you know, we can make some huge number. That's fine. That's 4 million. Make sure that's all good. Oh, we need to change this. Whoops. And then these actually need to be 32. There must be a better way to do this. Write these tests. Like, maybe call in a function that passes in the type. I don't know. Seems like I want to keep these tests kind of simpler. Okay. So we need to do a bool as well, huh? Yes. Fortunately, there aren't too many we have to do here. Do a 64. I don't remember exactly how big int 64 is. I think it's something like this size. I mean, it's huge. You can have it be massive. Okay, let's do a bool. And I think that might be it. For these. For this, what I think I might do is actually, I guess for these, oh, that's something I could have done is, oh wait, no, that's not true. I want to store the value. So I just want to make sure that this, since there's only like 2 possible states. 1 and 2. There we go. Okay, what else? I think that's it for our trivial types, right? I'm forgetting any. Then we need to do string, and then we want to do the vector stuff. I guess another thing we could have done here, maybe I should have done that, is require that the ReadStream size is equal to 1. And then this is 1, and this should be 2, and this is 4, and then this is 8. Oh, poop. That's wrong. Writer. There we go, and that's 8. Bad copy paste. Writer size is, in this case, it should be 2. Hey, fake, what's up? Digging is going good. We wrote a write and read stream for serializing and deserializing data. I'm just writing some unit tests for it. And yeah, it's going good. It's going good. How are you doing? How do you do a wide string? I know you could in the past do L. I don't know if that's valid anymore. What is that called again? Literal. C++ wide string literal. Oh, what is L? Okay. Nice. Oh, okay, and then U in capital U. I didn't know that. Okay, cool. Nice. Cool. Yeah, how are you doing? Fake. What's up? What's new? Oh, he's probably complaining because that was the wrong type. Okay, and now let's do let's try a vector. That's our like vec2. So for this, I don't know the exact size of this. I guess what it should be is a uint 8 plus a uint 32 for every character, right? No, it's a uint 8. So it should be 7. I mean, I guess what we could say is it's value size plus 1 is what we should get. And then for this, it should be value size times 2 plus 1. Because when we write the length, we only write a uint 8 because we're just assuming that we're never going to have any strings that are longer than 256. And so our vector should be just, let's see, it's a float. So it would be, I guess what makes the most sense is to say the size of our vector, which should be 4. Right? No. It'd be 8 because it's a float. Oh, I totally forgot about float and double. That's a good point. Float and double. What we'll just do is copy these and put them right here and say float. Let's say this is 42.1 0.95. And let's say that this should be a float. So I guess we do want that string literal. Yeah. We'll do that. You can do a _a, which is for approximately. So our float. Oh, whoops, we don't have floats are not. You can't have unsigned floats. I don't need two of those. Float. Have to specify it's a float, and then here it should say it's 42.95 a. Because we might lose some data there. Double. Double. Okay, I think that's all of everything that we should be supporting. Right array, ReadStream. Whoops, looks like writer. There we go. I like how you put an extra 2 digits of precision for the double. I don't know if that actually makes a difference. Like, maybe it does. I don't know if you're like joking. You're like, that doesn't really matter. Or if you're like, oh yeah, that's smart. Maybe it matters. It passes. I know, like, as you get further away from 0, the precision becomes worse. So maybe I should have some large number for the double. Okay, so yeah, all of those tests are passing. That's awesome. So one thing we have to do is, so what we did here is we made it so that we can specify a type as trivially serializable. You need something like 15 decimal digits to represent every double. Gotcha. Yeah, so you can specify something as being trivially serializable, which means that it can use this templated operator. And we do the same thing with our ReadStream. Where's the HPP? So all it just does is it does a mem copy and a size of. And so we can do this with our structs. So like any pod, basically. And also our vector and rectangle, since they're like super simple data. And I want to play around with this and try to figure out if we can come up with a better way to do this. But right now, it seems like I might have to do it like this, where I specify afterwards, which kind of sucks. It'd be cool if I could like have it be in here, where I could just say, oh, this is a rectangle. Like any constructor rectangle in here would have, or is trivially serializable. And maybe the problem is that I need to then include traits inside of here. Maybe that's the problem. Maybe. What we can do is just try to use a rectangle here. It looks like it's not being able to find it. Yeah. Wait, what's wrong with this? It should be a yeah, rectangle that. Oh, whoops. Sorry. This needs to be a rect. That was my bad. Yeah, so it's not being able to figure that out. It says that cannot be declared with const expression specifier inside of here. So is there a way to do this? Like maybe what we can do like I don't think it works, but maybe we can put in the HPP file. I don't think this is going to work though. Because I don't think that this would even run, right? Like nothing is telling it to run. Maybe you could do it like this. I'm probably wrong, but maybe. No, you have to have the context. No, that's not gonna work either. Yeah. We have a. Oh, maybe that's why. Duh. Maybe. So what is this template? Template type T. Type T. Maybe it's because I need to specify within here. Sorry, I'm not entirely sure how this is all working yet. So, my understanding is that we're saying, yeah. Sorry, someone suggested this code yesterday, and I guess I don't fully understand it. Or like why we can't do it here. Like I know we can make it work this other way. Maybe you just can't do this in here. I know we can do it like this. This works. So, is this setting traits is something that's new? Like doing something along these lines? Type traits. Let's look a little bit. I want to try to understand that better. So we're kind of doing something along these lines. But what I would like to do is be able to define it within the templated class. I'm not sure if you can do that. Like maybe you just have to do it after it has, like, after the implementation, right? Maybe what I should look for is like C++ type trait, templated class. It doesn't sound like what I want. This is kind of what I want, but not quite. It's pretty cool how it works though, that it will like be able to at compile time create the templated versions, but only if it's trivially serializable. Specialization, yeah. Maybe I just need to. I might just investigate off stream some, just so we can move on. Maybe I'll do that. For now, what we can just do is do this. We only need like 5 or 6. This is probably not the most efficient way. Hey. What's up, Azenris? Azenris. I don't know. Azenris. There we go. Azenris. Is the yes, it is. Yeah, we're working on finishing up the serialization. You can follow that link below. Yeah, the project task list is like, it needs more work. All of this website needs more work. I've just been so busy recently, and I haven't prioritized it. Okay, so we want pixel vector, and a tile vector, and a rect. All of these specializations, pixel rect. I'm sure there's a way to do this that's not like this, but I don't know how. And then we need to go into rectangle and just remove this. And then suddenly, magically, everything works. Azenris. Or is it Azen or Azen? Now, part of the reason that I was stumbling is my nose is quite stuffy. Azenris. Yeah, I don't know why. I always want to say Anzenris. So I'm like, wait, stop. You're starting to say it wrong. Okay, so I think we're done with all of this, right? I guess we could do tile vector, or like, technically this should be something more along the lines of this. And I wonder if this actually might complain. Oh, these are all floats. I wonder if it's going to mess up here or not. It shouldn't. I don't think it will. Because the bytes should stay the same. So it shouldn't mess up. Like there shouldn't be any floating point errors or anything like that. So we probably actually don't need that approximation stuff. $16. Oh, whoops. Wait. Oh, this needs to be a rectangle. That's what. Okay, let's do a more complicated can read write mini data, much data. So let's see here. What should we do with that? Maybe what we will do to make this simpler for us is we'll just say we have a transform component or transform one and transform and a physics component. And let's see here, that's an angle and a bounds. We'll initialize it. Angle. Why is it even like that? Actually, maybe I'll do it like this. Oh, whoops. Just kind of putting random numbers in here. Okay. And then we'll set up our physics. Dampening force. So we're just wanting to make sure that it can write a bunch of stuff in here. Inverse mass. Be something like 1 divided by 3.5, or yeah, that's right. And then our velocity, last thing, let's make it be 4.1. Okay, sounds good. So now what we will do is write all of this stuff to our writer. I'm going to cheat here some and just do this. Whoops. Writer. We don't want that. And then we are going to, let's actually move that up there. We're going to, so that's all the writing stuff. And we need a read. We're going to change this to 2. And there's our reader. And we need to read all of the data. We need to make sure we do the same thing. The easiest way to do this is to, oops, come on. So this is our reader. Change that from 1 to 2. And now what we need to do is just say that our, what's the easiest way to do this? Probably just split it again, right? Okay, and then let's see. I think I didn't actually write out something, right? I think I forgot to do, we have dampening, that was it. I didn't do dampening. But I should. Because if I do dampening, then we have all of them. And if we have all of them, then I'll have to make sure. Oh, whoops. No. Dampening is second to last. Dampening. We need to read it in the same order. Oh, whoops. And then the last thing is that we can just now say, oh, this should be the size of a transform component plus the size of a physics component. And now we need to include components in here, include siege component.h, dampening. Damping. Is it really just damping? I guess so. What's with that? It looks like I forgot 2 bytes somewhere. Bounds, angle, origin, and scale. Bounds, angle, origin, and scale. And then it looks like I'm missing a unit 16 somewhere. Velocity, force, gravity, scale, inverse mass, and damping. Seems like I got everything. There's 5 and then 4. Am I missing the angle? No, here's the angle. Oh, I forgot to make sure that the damping. But it does seem like I'm missing something in here. Line 471. Thank you. You're right. Thank you. That was wrong. That shouldn't. Like, actually, we would have caught that right here, I think. It should say, oh, this fails now. That damping 1 does not equal 2. Damping 1, yeah. But our size is still wrong. Are we writing anything else to it? Reader, writer, balance table. Yeah, I wonder what's going on here. The size is wrong. So it says it only has 66 whenever it thinks it's supposed to have 68. Well, maybe one of the easiest things to do is just try to narrow it down. Let's comment this stuff out and then say, now it should only be the size of a transform component. Like it's not padding. Maybe it is. 34, 36. It might be. It shouldn't. Okay, I guess what we'll do is we'll just whoops. One too far. We'll break here. We'll look at what's in writer. 0, 0, 160. Bounds. Okay, wait, what's up with that? Oh no, that's acceptable. Yeah, 160, 64, that's right. Because that is a float or something. Maybe I should use something else. No, because it says that, yeah, it's saying that the 34 out of 36. So we're not writing all of the transform component. Oh, it's padding on the transform component. I see. Gotcha. Yeah, I get you now. Yeah, it's the padding on the component, on the struct. Yeah, because it's a uint 16 at the end, and so it has an extra 2 bits. There. Right, that makes sense. I feel like this newest version of Visual Studio is slower than 2017. Perhaps. Copying them individually will ignore padding. Yeah, I see that now. Yeah, okay. So it doesn't really make sense to do that check then. Yeah, what we'd have to do, like one thing we could do is say, hey, this is trivially serializable, and then it would work, and we could even do that. But it does kind of suck that that is the case. So we kind of, maybe for things that we really care to like make sure they're as compact as possible, we need to make sure that they're aligned correctly. Packet or add a reserved variable, or just make angle U32. Yeah. I don't really know how to pack a struct. We can look at that. Hey gamer, what's up? So do I actually want to do packing? What's on today's agenda? We're working on kind of wrapping up serialization. Doing some unit testing for it. Almost done with that. So yeah, just data serialization. So is packing a good thing? I know like what you want to do typically is aligning, setting things up so that way it's good. And I believe I have that here where it's like the bounds, that's for floats, vectors, 2 floats, pixel vectors, 2 uint 32, oh, it's int 32s. And then at the end we have our int 16. So I don't have like a int 16 in the middle. I guess it's probably not great for optimizations, messing up alignments. I see. Well, then we won't worry about it for now. It's something I'll probably need to investigate in the future. I mean, for this, we could just say like, instead of that, it's just the sum of all the individual components because that's really what we're writing. I didn't consider the whole like padding for structures. So it'd be a rect is 16 and a vector is 8. So that's 16, 8, 24 plus another 8 is 32. And then a uint 16 is 34. So we have 34 plus 8, 8, 8. That's 24, 32. So it's 66. Which I actually saw was what it was. So one thing we could do, actually, yeah. I don't really want to do that, never mind. I was going to say I could make our transform component and physics component trivially serializable, but I don't think I actually want to do that. But yeah, in the future we'd probably write our own little function to be able to serialize our components. Yeah. So instead of doing all of this, we could just say, oops. Writer, let's do our transform 1. Whoops. And it just knows like, oh yeah, I know exactly what I need to do for that. And it would do basically this and then this. But for now, I don't know where I want to put that. We'll worry about that later. Okay, cool. I think that's all of the tests that we need to write for that right now. Stupid thing. Our reader and writer streams are in a good place now, I think. Okay, we got all of our tests passing. Excellent. Let's go ahead and commit all of this. I think it all looks good. And then we also have this over here. So, data serialization via read stream and write stream and read stream. Cool. Seems good. Very basic, but I like. So, yeah, in the future, one thing I'm thinking about doing is some introspection with the code and making it so that we could have things be automatically generated for our components at least. Maybe some other things as well. Maybe we could do that for all of our structure, you know, like, so the goal is that we are wanting to be able to somewhat like confidently, well, there's a few goals. So one thing is that we want to confidently use our data streams, our read and write streams, and know that we're not writing and reading in the incorrect orders. So like, you know, we can really screw things up if we go over to here and we're like, okay, well, we want to have our writer where it's writing, you know, force, gravity scale, inverse mass, dampening, and then velocity. Whereas over here, we accidentally put the velocity before the dampening. And then suddenly now we're swapping them, which completely screws things up. And especially, you know, if it's like just going to the client, and so the client is reading the dampening as velocity and the velocity as dampening, then that's, you know, just horrible. So that's one thing. Another thing is that, you know, it kind of sucks to have to write all this code whenever it's pretty much the exact same for everything. So what would be cool is if we could have this be somewhat automatic. So like our read stream and write stream functions would be written automatically for us. So, you know, right now we need to do something along the lines of void operator. So that's for the write stream. And then our data would be like our physics component. That can be a const physics, and then we would need something along the lines of this. So that's what our, whoops, that would be stream. That's what our function would look like. And then we would need another one, which is our read stream, which can't take a const because we need to be writing into our physics. So like, that's not too bad, but hey, we have to do that for all of these. And if we ever like move anything, like let's say that we were like, oh, you know what, let's change it so that, or, you know, like it could just be easy to forget, like, you know, maybe I'm not paying attention one day, and whenever I make our physics component or some future component, I set it up where maybe it has like, let's actually put that back. It has something like a uint8 data here. And then we're like, oh, whoops, that's actually going to be screwing up the alignment sum, and we're wasting padding or whatever. And so we want to move it, or we just want to get rid of it, or whatever. If I don't go update these two functions to properly, you know, reflect that change, like we move something, or I delete it or whatever, I change the type possible of a type. Fortunately, now that we're doing this, that won't hurt it. But yeah, still, like, there's some potential for us to have these things become out of sync. So one cool thing we could do is use some introspection here. And we are kind of talking about this yesterday, and I was like, yeah, I don't really know what I want to do with that. I'm still not entirely sure, but I have a slightly better idea. I was watching Handmade Heroes introspection video, which is actually really funny that someone mentioned this yesterday, and so I started watching it. Here, let me... I want a link to this Meta Pro. Okay, I think that's it. Here we go. So I was watching this yesterday. I didn't make it. I'm like most of the way through. I'm an hour in. But funny thing about this is that he did this during the DevStreamathon. Guess who hosted the DevStreamathon? This guy right here. And I was like, dang, I totally forgot about DevStreamathon, which was like 3.5 years ago. It's something I put together. It was like October 16th, 2015. Where I just got like all of the like dev streamers that were active at the time to stream like back to back to back. And so we had like, I think it was 24 hours of devs streaming. And so we had Handmade Hero and I think I did 2 sections. I think I opened it and ended it. And then we had like Robot Loves Kitty and Scott Studio and I don't even remember who. But it was cool. It was cool. It was stressful and I wasn't very good at it. There's a lot to learn in that regard, like trying to host events. I vaguely remember that. Okay, cool. Yeah. So it was kind of cool that like, I was just reminded by or reminded of that by this video. And I had completely forgotten about it. But yeah, so Casey was kind of talking about this, and we're also talking about introspection yesterday. But what I could do is instead of doing this, we could do something along the lines of using... I'm trying to remember exactly. I guess it doesn't do anything, or we could, I think you can do stuff like this. And so then we could have like a define client, which just does nothing. Define server or whatever. Maybe we would want to call this something else, like serializable is quite verbose, but maybe we could do it like that, or maybe like there's a few ways we could, like, if we wanted to like specify like, hey, this thing should exist on the client or shouldn't or whatever, we could also use that. But maybe we just want to say, hey, this is serializable and it doesn't actually do anything. And like it just whenever it gets compiled, it just is compiled out. And so then what we could do whenever we want to try to, like, yeah, instead of writing these functions, what we would do is we would read through our files, and maybe we would want to like we would like specify exactly which files, or maybe it could just look through all of the header files for structures that have a serializable tag in front of the type. Oh, sorry, in front of a variable. And it would just create this automatically for us. It would say, okay, well, we have a velocity, a force, a damping, inverse mass, and gravity scale that we want to be writing to and reading to. And we would say like, okay, well, anything that's serializable, like this needs to be trivially serializable, or at least it needs to assume that there's something else that we're generating it for that thing. So this exists somewhere. And so then we could just create some header file that has all of these that we can just run that generation, the file generation, every single time we compile if we wanted to. First thing we do is just generate it. So we would write our C++ code for us that, would implement this. Maybe it would probably need to create two files, one, the header that defines, just has the definition, and then C++ file with the implementation itself. But yeah, so that'd be pretty cool. And then we could just include that file and it would be updated. And then we know, like, hey, it's always going to have the exact same data and it's always going to be up to date. One thing we do have to also keep in mind is the whole like versioning idea. Is like, well, what if we change a component and it suddenly has different data within it? Like, I don't really want to be writing out the version for every single component, and so maybe, we could come up with some other ways to try to solve that. We'll have to look at how we are using the, like, reading and writing our data, because I think, at least for disk IO, or file IO, we're just going to probably take our entire component pool and just dump it. We're going to be like, if we go look at our component pool, it's not open here, component pool. We have our components, and we have a component count, so we're just like, hey, read, starting at the beginning of, components, read all of our component count times the size of whatever the component is, and that will like serialize the entire thing for us. We could even write a templated function to do that for us if we really wanted to, right in here. Yeah. I don't know. I'm not going to do it right now just because I'm not positive that's how we're going to do it, but I think that is. And one really cool thing about that is it's going to be very fast. It's just like dump all this data. Whereas like, yeah, so it'll just be like a mem copy of all of our components into our file buffer essentially. Yeah, that'd be cool. For netcode, I think our read and writes are going to be different though. We probably will be reading and writing our components on an individual basis because we only want to, like for our files, we want to dump everything. But for netcode, we only want to be sending the data that the client really needs to know about. And that's where we might want to in here specify like serializable, like maybe we want to say client serializable. Like well, for all of this the client would care, but for some other things, like our textures and programs, we probably actually don't care about that. I'm trying to think of a good example. Yeah, we don't have any here right now, but there's oftentimes there'll be data that the server cares about, and we probably want to like serialize it, but we really don't want to serialize it for. Yeah, I was just thinking about that. Yeah. Yeah, we might not care about sending it to the client, and so we might want to like specify when we do, or maybe say when we don't want to. Like perhaps we would say this is like server only, because I don't know, we'd want to look at what makes the most sense. Like or maybe we just say server. Like, hey, this is something that's only on the server. We don't want to sync it to the client. One thing we might want to end up doing in the future is actually writing a different stream class or read and write stream classes for the netcode. So that way we can overload this and have some of the code be more like optimized for netcode. And that's where this would come into play, where like, you know, our serializable would use anything that's marked as serializable would be used, and then anything that is marked as serializable and not server would be used for this other one. So like here, I mean, this isn't going to be the case, but if we did have it, so like our force and our velocity were not being, or they are server only, then we would have something along the lines of, let's just copy and paste this for now. And we could say like, this is our net read stream or read net. I don't know what we would want to call it. And our write net. And that just would not have our force, and it would not have our velocity. And same with this. So it would like not have that stuff. Because yeah, oftentimes whenever we're sending stuff to the client, we're not going to need all of that. So we can like really trim it down. I found there's like a few different things I wanted to do for Kriya when serializing data. Oftentimes there'd be like an initialization thing, like here's the state of this thing. I need to like do a full pack on it, which is like write all of the data and send it to the client. But in the future, we would only be sending like deltas of what has exactly changed for that component. I don't know exactly how we're going to want that to look in this new world where we're like really breaking things up. I haven't thought about that stuff at all, because it's like whenever we're writing our netcode, we really need to be thinking about like, you know, dirty components and what are we needing to send to the client. And I don't really know how that's going to look yet. Like, how are we marking something as dirty? Maybe that needs to happen inside of the world and on like the client level basis, or I'm not sure yet. Or maybe, you know, it's just being tracked. Yeah, I really don't know. And that's something I really need to be thinking about, is like, how do we know whenever something needs to be updated on the client side? And we need to try to minimize that. For Kriya, I had it so it's like, basically anytime we changed any data, let's say we go to like our equipment component. If we like set the level required, we would just mark that component as dirty, and then that would automatically that would be checked whenever we are sending the state to the clients. Like we'd say, hey, entity, do you have any dirty components? And it would say, oh yeah, I have this dirty component here. And then it would, you know, we would get that dirty component and we would write it out. We would get to the pack, and like this is one of the ones that I did not optimize, and so it's just packing basically everything. It's like, oh, this one variable changed. Well, now we have to send everything. But this doesn't change very often, so it wasn't that big of a deal. Like equipment changing, yeah, usually it's like we set it up, we send it, and it doesn't change again. Or if it does change, it's like, oh yeah, you did an enchantment on it, and it changes once, and that's it. And so it's not something that we're sending very often. And so it's just like, you know, I didn't optimize it because it doesn't really need to be optimized. Whereas some other components, like our inventory, is changing all of the time. And so you kind of want to pack that down. And so you might say, okay, well, instead of sending all of the inventory, let's track which items in our inventory have changed since the last time that we sent an update. And so we only send those, we only pack that those entities or those items. We say, hey, item 12 and 27 changed, and here they are. Yeah, I don't know how that's going to look in projectDig, but it's just something to keep in mind. I think I'll hold off on writing something like this until we get to that point. But this might quite possibly be what we want to do, and with the introspection we could do some cool things like this, where we can just say, oh yeah, this is a server serializable, so it's saved to disk, but it's not sent to the client. Yeah, could be cool. I think so. Let's just discard this. It doesn't like me. Here we go. So yeah, we'll do that. We'll look at that future day. I don't know when. But we'll look at that in the future. So now that we got that done, so this is like, we kind of have like a basic serialization. I am going to put it in here. It's not all the way done, but it's most of the way. So we can start working on something else now. I don't have time to get into physics today. Maybe on Monday we'll try to get back to our physics system. Yeah, I don't know if I'll be able to do it tomorrow either. But soon, in the meantime, we can look at something else. So I'm kind of digging this whole like just focusing on a bunch of fundamentals code. You know, we did our vectors and our rectangles and our serialization, and we also did a timer class and our spatial hash. So there's like a lot of like essential pieces of code that we're working on, but we still have several left. There's like events and delegates that I would like to do. I kind of need to figure out Unicode. I don't know exactly what I want to do with that yet. Kind of need to figure out like our font rendering stuff. No, you won't. Physics is never coming. Yep, you're probably right. Physics will never happen. The asset cache is important. So I'd say like these are really important. I don't know what I want to do with the hash maps yet. I probably don't want to implement my own because honestly, I don't think I know. Oops, sorry. I don't know enough about that. Like, I should just use an existing solution that's going to be way better than anything I could come up with because those people really know what they're doing. But I haven't decided what I want to do with that yet. I might go with the Google stuff. That seems like a fairly good solution. The like Google dense map. They have a dense map and a dense set, and then like a sparse map and a sparse set. And you know, that's kind of like weighing between memory versus versus speed. So the dense maps, my understanding is that they actually, I don't remember. It sounds like dense should be better for memory, but I think it's actually the other way around. I don't know. Anyways, so I think maybe what we should do. So our asset cache would probably be using at least our event delegates and maybe even a string hash table. So it might be that we want to work on our events and delegates first. I don't really know what I want to do with that though. So maybe we could talk about that today and see if we can start figuring out what we would like our events and delegates to look like. So, what is a C++ delegate? I saw someone, here's a response. A delegate is a class that wraps a pointer or reference to an object instance, a member method of that object's class to be called on that object's instance, and provides a method to trigger that call. I guess events and delegates are kind of the same. Well, a delegate is more of like the underlying part for an event, right? Where you might have an event that says, you know, hey, this thing happened, and then you would have a bunch of delegates that would be calling the functions that are associated with them, where it's like, oh, okay, well, now that this event's happening, let's do, you know, X, Y, and Z, you know, based off, given that you have delegates X, Y, and Z. Yeah. Dang, look at all those options. Functors, lambda expressions, function pointers, pointer to member functions. A std function. Yeah, this is the most flexible one. But it's also one of the slower ones, is using std function. Probably what we would like to do is support multiples and like opt for the fastest one. There are fast C++ delegate. There are some solutions out there already, and maybe we should just use an existing one. And maybe what we could do is add onto it or something. Man, they get kind of crazy with their templating and everything. Yeah, for Korea, I pretty much just, I don't even know what I used. Now that I think about it, what did I do? Event. I think, oh yeah, that's right. I don't know. I don't like what I did for Korea. That's for sure. So what I did is, well, for one, I didn't use templating. Look at this. Like, I could make this so much better now. I actually know how I could improve that. Yeah, I didn't really know about templates, and also I didn't know about Veridic templating, and I'm also not using C++11, so it may have not even worked. I don't know. I think it would have, but I didn't try. Anyways, so oh yeah, here we go. Our listeners. So for this, I just had a list of Python objects. So you could add a Python object, and it just would assume that's a callable Python object. And then you could remove it. and whenever you invoke, it would call the listener or all of the listeners with that. And so that was the event class. It's like super simple. One thing I really didn't like about it is that it was separate from, I couldn't store, and I wish I had just done this, is like, I really don't know why I didn't do this. Is this add in here like you know, std vector of like this would have been so easy to do. And then it would be like, so this is listeners, and this is also like listeners, listeners 2 or whatever. And whenever I invoke it, or like I would support adding, you know, a listener that has a std function, and then whenever you invoke, it would just call all of your listeners and then call all of your listeners too. What if you need more than 9 args? I never did. But yeah, this was ugly code. I know I wrote it a long time ago. It's okay. We're doing a better job with projectDig. So yeah, I do wish I had at least done something like this, because what ended up happening is that in a few places where I'm like, oh, I kind of would like to be able to call this from, or have a listener in both C++ and also on the Python side, I had to do some janky thing. Right? I mean, it wasn't too often, so it wasn't like that big of a deal. But there were a few places, like this one in particular, I know I ran into the most, which is that I have this event on destroyed, and then I have this on destroy signal, and that's how I handled all of, and I don't know why I did it like this. I don't know why I use signals. I hate signals now. But that's what I ended up using for the undestroy. Is basically whenever you destroy it, it calls both undestroy, invokes that, and then it calls the undestroyed event. Let's check this out. Mooballs says they have an implementation of a non-allocating std function that's proposed. Oh, interesting. Non-allocating. A library of study group 14 of working group 21. What the heck? Did I miss it in here? Oh, it's in place function. That's what it would be. Boost software 2003. Surprisingly small. $2003, that's pretty old. So it's proposed to the like C++ standard. Ugh. Maybe they just copied that. I don't know. Yeah, it's not that old. Yeah. I was thinking, I'm like, they mentioned std function in here, but like, wasn't std function introduced at C++ 11? Yeah. That's cool. Yeah, we can. I mean, I don't know if this is like intended for people to actually use, but it definitely looks cool. It's interesting how they actually like talk about games. They're like, hey, this looks like it might be useful because people are doing stuff like this in games. But yeah, it also sounds, they say it's intended to be like a replacement, so you could just drop it in. So like we could use the std function if we decided we could like, see how this works out. And if it doesn't work, then we could just go back to it or something. So what we probably should do, maybe what I'll do is I'm going to put that in here as, wait, what is this? That's a comment. Yes. I think I'll add that as a comment. It's the working group for games. Oh, okay. I see. SG14. I've never found std function to be too big of a performance cost. Yeah, I mean, you're right. It probably depends on how much you're using it. Like, if you have, like, some people are like super event driven where they're like, all of my systems won't talk, and instead, I'm just gonna have a messaging system. So if I ever want to call this, like, my health changed, let's send an event, and anything that ever would want to, handle my health changing now just listens to this health change message. And some people are like, go crazy on that stuff, and I imagine then it would start to be an actual like performance issue, where like everything is stored as a function. And yeah, we're not doing that, so maybe it's not going to be a big deal for us. And so like maybe we could just use std function for now, and then profile it in the future and see like, oh, if this is a problem, then maybe we can just like replace it with something else. So what I'd like to think about to start with is this, like, what is our use case for events? And maybe we don't really even need delegate so much, because std function is basically a delegate, right? It's something that's holding this function for us, handling all of that, so we can just invoke this function. And so what we can do is write our event class in such a way that it more or less just like obfuscates the underlying delegates. And in the future, we could change our delegate implementation if we need to, like, oh, let's use this in place function instead. And it should hopefully just be able to, be like one or two files that we would have to change, and it would update all of the delegates throughout the entire code base. But yeah, let's think about how we want to be using our events, and like, yeah, just some use cases. And so then we can try to come up with a design for our events. That makes sense. By the way, welcome Kyle and Mooballs. Hope you guys are having a good Saturday. Thanks for joining. So events. how are we wanting to use events? Let's think about what we did in Korea, and then maybe we can like transition over what we liked, what we didn't like about that, how we could change things. So in Korea, I used events a lot. It was a way, and so this is something, yeah, I might want to change it. Like events, I feel like they can be good and they can be bad. So events basically make it so that we can have our code be very flexible, where we can allow gameplay to kind of inject itself into various places and just say like, hey, let's do this thing here or do this other thing here. Let's handle this event like, oh, someone took damage, let's do something. Or yeah, I use it in a lot of things. Like, so for Korea, if I wanted to be able to have something occur every single update, what I would do is I would just especially for Python, I use the events for Python a lot. I would have it just add that function to the onUpdate event that was invoked every single frame at the beginning. And then I also had like a fixed time step one. So if we didn't want it to be for the frame, we want it to be the fixed time step, you'd say, oh, we'll just add it to the fixed time step update. And then I had other things like, whenever the entity is destroyed, that would oftentimes be like how I would handle tearing down the entity. So like if an entity let's say that we wanted to register or like hook up an entity to some system where we're like, hey, we are interested in like watching this particular thing, or like, let me come up with the actual example. Let's say that in Korea, if we wanted to have one monster follow another monster, what would probably happen is that we would say, hey, just keep following the monster or following this player, and then we could add a callback to the onDestroyed and say, hey, whenever the or whatever the entity is following is destroyed, then stop following it. Make it so like we set the like follow target to null, and then it just maybe we only check that. And so that way we'd actually like clean it up, remove that pointer or whatever. I don't like that so much. That might not be the best example, because what I probably actually did was say like, hey, if this entity is destroyed, then unregister it. So it'd be a check instead of a callback. But that's kind of what would happen. I also used events or callbacks, whatever, for arbitrary things. Like, let's say the player wants to interact with the door. I would have the door entity would have an event component, and then that event component would have an interact event associated with it. So the event component had a map of name to events, and you could say, hey, give me this event and then add this listener or invoke it and invoke that event. And so you would say, hey, the interact event should have this, interact door callback or listener. And then, later, whenever you interact with the door, like you hover over your mouse and you press E, you interact with it, we would check to see if the entity that you are trying to interact with has this interact event, then we would invoke it and call that function, you know, let it do whatever it wants. You literally just described a weak pointer to follow a target. Yeah, I know. Like, it was probably a bad example. I'm sure I could have come up with a better one, but I mean, it's not what you would want to do. But anyways, so that's how I would handle all of the like game logic, is that we would just have that event stuff. You know, you could do it other ways, like, well, the reason we would need to do it that way with the whole like event callback is because I had all that code be spread out, and so it wasn't like in any table or anything like that. You know, if you wanted to be like, you could have just an interact function that like checks the ID of the entity and then has a block of code that handles that interaction or something. Like, that's if you don't have it, have that code be spread out. But for us, I guess door. Here we go. Here's our door. Here's our interact door. So whenever you interact with it, so you can see here we say, hey, this event, the event for the event component for the door has an interact event, and we want to listen to interact door, and this is what would be called. So you could, you know, put this code in some place where we actually check, like, hey, if this is a door that we're interacting with, call this, instead of having a callback. I don't know if that's how we want to handle things. I haven't really thought about how I want to do the code for projectDig. I think I might go that route. Maybe. So having all of the like interact code be inside of a C++ file. Maybe I just have like a huge interact function. Probably, you know, and then block it where it's like, here's for a door and here's for this other thing. Yeah, I could maybe see some, like, there's definitely some like huge benefits to having this code be in, you know, Lua or whatever if we decide to do a scripting language. But I'm not sure. It's kind of tricky because, you know, let's say that we have this interact door and we want to change some stuff. I really need to think about how we want to handle like the netcode for this, because if you, let's say that you want to interact with the door, and so this actually will open, so what I ended up doing is making it so that when you interact with the door, and I don't know why this is on a separate line here, it actually then calls the open or close event. And I did that because I wanted to make it so that this code could be, or like you could invoke those events through other means, like, you know, you could hook up the door to a switch that, oh, here it is. I would call this event. So you could, whenever you power on or off a door, it would open or close it. Or maybe I would want to be able to do something like say, hey, let's close all of the doors in this dungeon, or open them all, or whatever. And so I could just call that open event and it would handle it properly. And some doors will actually do different things based off of what they are. Like, I think some doors will like have a light source that turns on or off based off of if it's open. I don't remember. Just stuff like that. But it's whenever you open or close the door, it's going to have some state changes. Like it might play an animation, or it might, activate or deactivate the collision for that entity. And that needs to be able, and I need to figure out a way to do this where I need to tell the like whatever something like the net code manager, whatever, that hey, this entity has changed, and if anyone cares about this entity, they need to get an updated version of that entity data. Like, hey, this component is now dirty. Or sorry, this collision data is inactive, or hey, the player moved to this location, or whatever. Like, their health changed. We say like entity.stats.hp equals 10, we need to be able to send that data to the clients, and it needs to know that that's happening. And whenever you're writing code in Lua or in a scripting language, stuff like that just seems like it should happen automatically. And so, it'd be kind of weird to have to say like, oh, hey, also do this other thing. And maybe I probably should come up with some like nice way to handle all of this. I'm not really sure how I want to do that yet. It might be that like we have our entity data, or like right now we don't have an entity class, it's just an ID, but maybe whenever we are sharing it to the Lua script, maybe we want to like create some entity object that we pass to this Lua script, so that way it could do things with it in a more intuitive way, where we could just say like, oh yeah, it's an entity, and if you want to like access the physics component, you can. um and then that could have like wrappers around the data, so um if you say, change the HP stat, then that that component gets marked as dirty or whatever, and it knows exactly what needs to change whenever we're sending data to the clients. Yeah, just trying to think that out through. Notice my autofocus was happening. Yeah. Hey, give me 1 moment, guys. I need to check on my daughter to see if she's awake from her nap. I'll be right back. Okay, I'm back. She is amazingly still asleep. She's been asleep for like 3.5 or about 3 hours now. Okay, so just kind of thinking through a lot of this stuff. Yeah, I'm not entirely sure how we want to use all of this. So another example that I can think of, which is probably one of the, and this is like why I kind of brought it up, is that we would be using the events for our asset cache. So the asset cache will be loading files, and we want to be able to handle when data is loaded. So I was talking to T-Lock or Tim like a week ago about this stuff. And he showed me some cool things that he did with his engine that I would like to try to handle. So one thing he did, let me see if I can describe it like what he was telling me. Let me just delete all of that stuff, everything. Inject. Okay, there we go. So basically what he does, and I like how this sounds, is that he has like an interaction pointer. And so he would have like three things here. So let's say that so this is our like pointer, or the handle, I guess is what you could call it. So this is our handle. I like the H being lopsided like that. And then this is the actual like asset. And then we have our I think, I guess this would be the data that we'd store. So this would like be in our component or something. So what we'd want to do is, let's say that we have, so right now in projectDig, if we go look at our components, okay, we already are there. We have a texture handle and a program. And so our texture handle is pointing to a texture. How is that handled actually? I'm forgetting of that. Render system. So, should be up here. Render, yeah. Set texture. Here we go. So we have our texture here with the texture data. Textures, right? Yeah, and the texture data has a texture handle which is for our BGFX. And so we are storing this texture handle in here, but this is waiting for a texture to be loaded. Let's say that we don't want to wait for a texture to be loaded. Then, so like right now, all we're doing is we're just saying like, hey, we want this component, our render component, to point to, let me actually do something like this. I think this would be best. And let me just draw some more lines because, man, I love drawing lines. It feels so good, guys. More. We need more lines. Okay. So now that we got that, here, I'll make a new layer and then we'll just get a nice little color. So right now, pretty much our world is just these two. Where if we have a component, it points to this handle. And so if we create a new component, it might, point to the same handle, or it might point to a different handle or whatever. It's going to point to one of these. And that's it. But that means that we're having to wait here. We have to wait for our the file to be loaded, and so that way we can get a handle to the actual data. What we would like to be able to do is instead say some indirect thing here where we would have our component would be pointing to this like handle, and maybe I should have like flipped these around. Maybe I should flip those around. Like let's call this our handle, and then this can be our asset. That probably makes more sense, right? I don't know. Maybe it doesn't. Maybe it doesn't. Maybe it only makes more sense because I'm currently calling this our handle. Is that right? Like the handle should probably be pointing to the asset. But anyways, so what we would like to do is be able to say, hey, it's whenever we create this new component and we're wanting to set it to our like the asset. Does it make sense? Yeah, I think this is okay. Whenever we want to set it to a handle, what we want that handle to do is like right away return and to say, hey, this is great. We have our asset loaded, and it might be like a it'll point to some like default checkerboard image or something like that. And then what would be happening behind the scenes is that our file loader would be loading the file. I meant to draw like some lines, but that didn't really work out. I was wanting to do this. Okay, that's not right at all. What is this? I think it like this. That's what I was wanting to do. Oh man, look at that beautiful art. So it's loading. Why did I do that? It's loading the file. It's so beautiful. And then in the future, dang, I was drawing on, I'll have to delete that because I was drawing on the wrong layer. Annoying. So it's pointing to some like temp asset. This could just be a temp file here. Temp. Oh man, come on. I'm so good. Okay, there we go, temp. Man, it started off good and then it just got not so great. So anyways, what we would want to be able to do is to say, oh, you know what, actually let's our file has loaded and now it's pointing to this over here. And from the component's point of view, it doesn't care. We don't have to go update that component handle because the underlying file is the thing that changed. Like the underlying asset underneath the handle itself. And So that's pretty awesome. I think now I'm thinking about it, maybe we don't need events for this, do we? I guess we would want like an event to be handled when we're loading up the file. Like we would need somewhere to update this handle. So we need some like handle or like asset cache or whatever would be pointing to this handle. I don't know exactly how this would work with BGFX. I guess what it would need to do is whenever the file is loaded, it would need to do this create texture 2D. Yeah, I guess that would be what would happen is like this asset would initially be pointing to this temp file. So we would have a BGFX texture handle that that this handle is pointing to, and then whenever we finish loading the file, we would want to update that. Say, okay, now we're actually pointing to this other one, and so it's just like a one layer of indirection. We could even have these handles just be like an integer. And I think that's what they do with BGFX as well, is like it could be the handle itself can actually just be an index to an array of texture handles. So we would have like it would just be like a vector of BGFX texture handles. And whenever we would want to get the actual handle, we'd say, so this is like the, I don't know what we would want to call this, but we would just say handles, and hey, this is our handle, or like our render texture is the handle, or the handle index that we would get our texture handle from. And so that way we can just like change it whenever we want, however we want, and it won't like be bothered by that, which would be pretty cool. Yeah. One thing, somewhat unrelated, one thing I'd also like to think about in the future is making it so that our textures can be maybe, I don't know how important this is. I was thinking like generated at runtime. It might make sense for some things, it might not. But it's something to at least think about. It could be that I could do it in our pipeline. So, we have all these individual assets. And this is something I really should have done for Korea, but I didn't. Because Korea has a lot of assets. But, I mean, we can just look at, like, our item basics, or not basics, material. So we have all of these graphics here. And there's so many PNG files. I mean, we're talking about like, there's probably 20 or 30 PNG files in just this one. And so it wastes a ton of time. Like anytime we want to draw an icon to the screen, we have to go to a new texture and load it up. It'd be so much more efficient if we just like took all of our icons and dumped them into like one huge file. Just like a 2048 by 2048 image, or I don't know if we'd have to have it be that large. It might fit in like a 1024 by 1024 or something. And we'd have all of the icons in that one file. And so whenever we're like rendering all the icons to inside of a UI or something, it would be much faster. We could even blit it if we wanted to. I recommend the Celeste texture atlas generator for your workflow. Chevy Ray. I think I may have seen this. Oh, he just released it, right? Is that right? Oh no. Never mind. That's 2000. He was talking about this a while ago. Yeah, I follow Chevy and whatnot. Yeah. Okay, cool. Yeah, I'll check it out. Nice. This is a command line tool that will pack a bunch of images into a single layer image. Yeah, I have texture packer. I don't know like how they really differ. I think texture packer might just be like way more complex. But I mean for most games it seems like this would probably be just perfectly fine. But yeah, with texture packer you can do a bunch of things here like changing how you want to pack it. You can like sort by name, or you can say, hey, I want to maximize this as much as it can. Yeah. And then you can also do stuff like, oh, it has to be a power of 2. But one thing I didn't do, and this is something I like to do, so we did do this for Creo to some degree, like obviously here I pack all of the monsters animations, but I only would do it for stuff like this, where I didn't do it for like disparate items, which is something that I think would have been really helpful, because what I just did is I would say like, hey, this uses the if we look here, this is the ancient key.png file, and whenever I would say ancient key.png, it was like super literal, that's the ancient key.png. But what would be cool is if we were like, hey, this is the ancient key PNG that we want, but actually ancient key.png is mapped to this specific texture, at location 128 256 or whatever. And so it would know exactly where it's at, like the texture rect for that texture. And so it's just like some mapping that would happen. And so that way, like, it kind of wouldn't really matter where it existed. I would just say, like, on the outside, I would just always say ancient key, and the underlying system would know what that means. And I think that would be really cool. And then you could generate the textures either during your pipeline, your asset pipeline, or during runtime if that matters. Like, I don't know exactly why you would want to do that, unless it was like you were procedurally generating the icons or something, which maybe could be cool. So you're like, oh yeah, I want to procedurally generate all of these icons and then store them in this texture, and then whenever we have this item that's maybe also procedurally generated, it would point to that texture or something. I don't know. I don't really know why you would want to do it at runtime unless it was like being generated somehow, like the graphics were being generated. Otherwise, I think you might as well. I guess another reason is if you're like exploding things out, like an example is if you're we're talking about using spline and it's not spine 2D. And spine 2D has like a lot of complexity that you can do with it, but you can, I'm pretty sure, just render your animations out to a PNG file, like a spreadsheet. Yeah, here they talk about it kind of, I think. The spreadsheet versus using spine where it's like, interpolating between the frames and everything. So, yeah, here's like here's what the texture is versus the actual spreadsheet, and so you can see all the graphics in here. And so if we were so yeah, the top one is the spine texture atlas, whereas the bottom one is the spreadsheet. If we wanted to, something like this, it would make sense. Or if we were doing something else, but along these lines where we're like, okay, let's have all these parts and then put them together, that might make sense to do at runtime as well, to keep down the bloat of the disk space. Or maybe also like being able to only load up exactly what we need. Like, hey, let's put together this entity or whatever, or this thing. But we know we're not going to need this half of it, so let's not even generate that half. I need to get some water in a moment. My throat's dry today. Hey boo, what's up? So yeah, I could see that being a reason why you'd want to do it at runtime. Otherwise, we just do it whenever we are generating the files. But then, yeah, it would be nice to be able to have some like redirection. So we would be able to just say that the image is one thing, and then like, hey, we have this ancient key and the mapping, it would like, we would do the asset pipeline, and it would end up putting into some like huge icon database or icon image with all of the icons from the game, or maybe the majority of them or whatever, and we would just be able to key into that kind of. But yeah, not entirely sure how I want to do all that, but that's kind of what I'm thinking. Need think about it more. But give me one moment. I need to get some water really quick. Okay, I'm back. Sorry that I was gone for a minute longer than I expected because Kaylee woke up. Gotta get her up and change a poopy diaper. Yay, fun. Um, and now she's being watched by Uncle Austin. Um, a fermented crab. Welcome. And welcome anyone who has joined. Thank you for being interested in what I'm working on. I appreciate it. For those who don't know what I'm working on, really, it is a new game that I'm currently calling projectDig. It's a 2D multiplayer automation survival sandbox game. Easiest way to think about that is Factorio meets Terraria side view game with sandbox elements and automation stuff like conveyor belts and huge fans blowing items around and item cannons to fire items around the world. And so you're just trying to get items to your factory, and then you're trying to process those items and hopefully doing that in a fun and interesting way. So we're using we're making a new game engine with SDL, BGFX, and lots of other like smaller libraries. Our engine is an entity component system, and we're also doing a lot of like data-oriented design, or at least trying to think about the data as we're setting things up and not just defaulting to object-oriented stuff.
To the park.
Okay, park.
Where's her? Is she okay to go like this? I put some sunscreen on her.
Sunscreen would be good.
Where's the sunscreen?
Let me get it.
Okay.
I'll be out in just a minute. Yeah, and I am streaming all of the development here on Twitch, and then uploading the VODs up to YouTube. I'm streaming every single day. You can see my schedule down below, which is 8 a.m. Pacific time, and during the weekdays, and 1 p.m. on the weekends. And I usually stream for somewhere between 6 to 8 hours. Except for on the weekends, it's more like 3 to 4 hours. But yeah, you're welcome to follow, and you also can follow my YouTube and whatnot. YouTube. I also recently started a Patreon where you can pre-order the game and get access to the code if you are a certain like reward tier or whatever they call it, patron tier. So you're welcome to check that out. But yeah, so anyways, that's enough that. I need to go find some sunscreen, and then we'll come back to looking at our events and maybe just focusing on that and not worrying too much about like all of the possible use cases. I think we can write something very, very simple fairly quickly. I'll be right back. Okay, I'm back. All right, so yeah, we're looking at events, and I think what we'll just do is use std functions for now. Just do something really basic. What would be nice is to be able to use events as a name, but then do like a string hash map with that. So we could basically have, let me make a new, I don't know if it really belongs in utility. Maybe it does. The new item includes seed utility. Let's call it event.h. So Eldrone, 4 months in a row. Welcome back to the siege. Hey, thanks for keeping your sub active. I appreciate it. That logo is the coolest. Yeah, Cooler made it, and it is really cool. Yeah, I'm like using it everywhere now. I'm like, thank you very much. I hope things are going well for you. Yeah, I like it. I like it. Okay, so let's just think about what we might want this to all look like. Let's set up our namespace and our class event. We might want to, I don't know what we want to do. I think we probably won't. Yeah, maybe, I don't know what we want to do with this yet. I guess our event, we probably would want to have it so that our, I'm trying to think of how, it's going to be different from the one I did for Korea. Like, we're going to want templates in some fashion or another here. Right? Or maybe we don't need to. So we're going to have a function, right? Is that no. Is where does, okay, it's not that. I'm going to save this. I don't know where I want to do that. Tile map, animation, rendering. Maybe I'll just throw it in here. Should definitely pack pack our textures during the asset pipeline. This is one possible solution. Okay. Oh yes, I was wanting to look up function. Where does that live? It is in functional. Okay, it is in functional. So what we want to do is have, I would say, a yeah, right. So we need, whenever we have this function, we need to specify the type of the like Yeah, basically we need the signature, right? So that's probably what we need to do, is provide the signature in here. I don't know what that would look like. So maybe we would say that it's always void. And so we do something like type name T TSS or something like that. Jeez. I'm forgetting how to do this. Wait, was it the other way? Yeah, there we go. So that will make it so that we can provide any number of arguments, and then we would have like a we would want a vector of functions which conform to that. I don't know if this is right. I'm just writing code. So these are our callbacks that are interested. So what this says is like expand out. So whenever we make an event, we could say, oh yeah, this is an event of, and we might actually want to like type def this or something. I'm not entirely sure how we would want to do that. We could say, oh, this is an event that takes an int. And whenever we add to it or call it or whatever, that would need to be siege event. We would then be able to, yeah, we can add, let's say like void add. And hey, Smile, what's up, man? How's it going? That's right, we're digging away. Dig. So this would take a function of t, and so that would be like our callback. So that's how you can add a callback. I think, or maybe actually we'd probably want to call like listen. Yeah, maybe something like that. So then we could say, oh yeah, we want to listen, and if we have a function like void f, which takes an int, it could do, something like that, printf, I, whatever. And so then we could pass in f. I'm not sure how accurate this code is, but not by ref and move in. I'm not sure about that. What we'd want to do with that exactly. This is actually wrong. It needs to be more like that. Right. Oh wait, no. Sorry. It needs to be function void t like that. And yeah, maybe really what we should do is say like this is our type name is callback or whatever. I mean, can we do can you do using in here? Would that work? Using callback is this. And then we would just say, oh yeah, this is a callback, and this is a list of callbacks. I think you can do it like that. I don't know which one is like the preferred when we have it templated like this. But yeah, I guess this is the more like C++ way, right? Oh. I don't know if it matters. I guess this depends. Do we want it to be public? I guess so. I think so. We could say, yeah, it's public. But yeah, maybe we want to like pass it in by reference or something. Probably. I don't know exactly what the... I mean, we probably almost certainly don't want to do that. Like, can we pass it as a const ref? Does that even make sense? I mean, most of the time, whenever we're creating it, we want to just be moving it, right? I don't know exactly how that should work. Yeah, we can worry about that in the future. Right now, I'm just sketching out some stuff. So then, yeah, I guess for this, like our just simple event, it doesn't worry about having some name associated with it. Later, we'd probably want some map, like our maybe let's say, yeah, I don't know. Yeah, so for Korea, I had this event component, and then the event component could have any like arbitrary number of events on it that would be mapped. So we would have, like maybe an unordered map of like a UN32 to our event. And so then you could say, oh yeah, I want this event at this. What would be preferable is if we could do something along the lines of, say, like interact, and then have it give it some literal like hash or whatever, or maybe we could just say _h or something like that to hash it. And then we could just say like, oh, let's listen to f, and it would be able to hash this into a uint32, or maybe we would say 64 or whatever. I don't know what our hashing function would do exactly. I haven't done that yet. But that's what I'm thinking. So yeah, I guess we wouldn't need a string hash map for this. We just need a just some hashing function, so that way we could keep this readable, but also make it so that we're not having to look things up with strings, which is something I did a lot in Korea, which is really bad to do. It's like, can't believe I did that. It's just, I think it's like, it's okay for a lot of things, but it's just so bad for games. Like, it's so slow, where it's like, I don't know. I guess whenever you're doing an unordered map, like the problem is that it has to do it has to hash that string every single time. Whereas if we do something like this, the string literal, it will hash it at compile time. Right? I think so. I think you can make it do that. I hope I'm right. I think so. And so we'll just hash it. I'm pretty sure, like, as long as this string literal is const expression, which I think it is, or you can make it so it's that way, then it would be at runtime. And so just like convert it over into the hash, keep this readable, but also make it so it's just a uint32. It doesn't have to rehash it every single time we're doing a lookup. But anyways, so we have a listen function that we would want to have. And then there's we need some like remove. Remove. And so this is where it gets a little weird. Is that like, how do you remove a callback? Maybe you can do it like this. I don't know what the like comparison is. Like, how do you compare functions? Here we go. Compares a std function with a null pointer. Empty functions compare equal. Non-empty functions compare non-equal. So you can't compare two functions. Okay. How would you do this then? Comparison between cannot be implemented well and therefore will not be implemented. Okay, yeah, sure. Yeah, I mean, maybe that's a drawback with using std functions as delegates. That you just can't do it. Deduction. Yeah, so maybe we would want to come up with some other way to do this or something. I don't know how often you really want to like be adding and removing listeners. I know it does happen. I know one of the most common things though is that like we'd probably want a clear function which just removes all the callbacks. So like yeah, this right now wouldn't work. I'm going to just put a note here. Cannot compare callback or compare std function. So this makes it. One thing you could do, I suppose, is have this return like the index. So, well, I guess that wouldn't work if with our vector. We would have to, yeah, this would have to be like a map, right? Or our vector couldn't reuse. That would be kind of bad. It'd probably be best to actually have this be like an unordered map, which kind of stinks. I mean, this is a possibility. Maybe I'll just put some notes here. Cannot compare. I don't really know what all of these are. List returns a handle ID and that is the input to remove. Yeah, exactly. The thought. Idea could return a handle or whatever from listen, which is used to remove it. Or a vector of a new struct containing an ID and the function. Yeah, and then you could iterate through it, sure. Yeah, but you don't remove a lot. You don't. Yeah. Yeah, that'd probably be the best solution, just because you're probably removing a fraction of the time that you're actually iterating. Like you want it to be, you want to be able to iterate over them as quickly as possible because that's what you're going to be doing most of the time. Hey, Soul Foam, what's up? How's it going? So yeah, maybe we could do that. It's an idea. So there's two things that we want to be able to do with a function. So one is like you can't remove while we are iterating over a function. I mean, like let's say while we're calling the callbacks, so we're inside of a callback, how do you remove that callback, or how do you remove other callbacks? So I think I did this in Korea. I might be wrong. But I think no, I didn't do that. Listen, invoke, remove if listeners is empty. I did not do that. I guess I just never allowed it. So maybe it's not that necessary of a thing or something. One thing you could do is whenever you're like invoking, you could um you could set some flag that would say, hey, we are currently calling, we're currently invoking, calling all of the listeners, queue up anything that, like, if you try to remove, like if you try to clear or remove, it would queue it up to happen later. That gets a little tricky. I never really did in Korea. So maybe it's not necessary. I could see there maybe being a like this could be worthwhile. It's like throwing in here a like invoking or whatever you would want to call it flag, and so you'd want to default it to false. But what you could do is whenever we do call invoke, we set it, and then inside of probably all three of these, listen, clear, and remove, we would want to just put in assert that it's not invoking. And so that way, if you ever try to listen or remove or clear, whatever, you're trying to modify the event while it's running, you can just get an assert, have it fail, so that way you can know that you're doing something wrong that you shouldn't be doing. Because I think, like 90% of the time you don't need to do that, or 99% of the time or something. And then the like few times that you do need to, it could, you could figure out a way to work around it or something. I don't know. One thing you do a lot with this, at least I found, is removing a callback while it's running. And so, one thing I might want to do is say that so I'm not sure about this. This is what I did for Kriya. We can think about like maybe we want to do it differently, but we could just say, hey, all callbacks need to return a value. And that value could be if this function or if that callback should remain or not. I think that's the thing that makes the most sense, is if it remains. And so if we return false, that says to not keep the function around that callback. So you should always like default to returning true, but sometimes you want to return false. Hey, you're doing this thing, you're watching for something to happen, and then hey, we finally had that thing happen, return false. We want to stop watching for it. And so yeah, it's used a lot. So we might want to do something like that. So then we would have a void invoke function. Oh, sorry, void invoke. Do we need a value? I don't know if we need any return values from any of these. I mean, listen if we want to have the handle. Besides that, though, I don't think we do. And so this would just be T. Dot. And That's it, right? I think so. Makes sense. It's really simple. And so whenever we are invoking, we just say iterate through the callbacks. Well, we can actually implement this. This is really simple. So let's this is going to be event.hpp. So we'll just include event.hpp. Yeah, so right. Right now, I'm just saying that it's not returning anything. We might want to change that in the future. So that's our listen. Oh, whoops, invoke. Wrong thing. I didn't mean to do that one. We will do that though. Oh, and this needs to be H. We're including itself. Sounds like a good idea, right? So this would be listen, callback. Yeah, we probably want to make this be like a reference or something. So this would be listen. So this would be, yeah, maybe we want to say assert not invoking. So we need to include the asset or assert util here then. And then invoke. I mean, maybe we want to even do it here, and then we would just say invoking is true. And then at the end, we would say invoking is false. So that way we just make sure that we never run into that. For this, we would want to say for iter equals I, or callbacks begin. And the reason we want to do iter rather than a for range loop, whoops, we don't even want to do that, is because we don't want to do anything there either. This is intentionally left empty. We want to say that, well, we want to, yeah, probably do something like this. For iter t, so we expand out, I think that's right, whatever it is, and if that returns true, so that's our function being called. That returns true, then we want to keep it, which means that we should do increment iterator. Otherwise, if we return false, it means that we need to remove that. So we need to update the iterator with our callbacks and erase whatever is at the iterator, and just do that. So pretty basic stuff. That seems good. So that way, yeah, if we return false, it will remove that callback. Yep, seems good. And then this would just be callbacks, pushback, callback. The other one is clear. Whoops. Which is called clear. And again, we should never, like, basically all of our functions should not, or we should not be able to call while we are invoking. Like if we ever try to modify our event, then something very bad is wrong. The reason I want to do this is because it can become not very obvious that that's happening, where it's like we might have a function that's calling another, we can have a callback that's hooked up, that's calling a function that calls another function that then is trying to like clear out this events or whatever. Like, yeah, it's just like, it can be a chain, call chain, and just. Yeah, it's just it's not obvious that's happening. You know, that code might be written at different times, and so it's like, you know, you might write the callback, and you're like, okay, I'm calling this function, and let's look to see if it's doing anything with the events. Oh, it's not, great. And then later you change that function, the function that's being called, and you're like, oh, let's actually clear this event here, and you don't even think about it or something. It definitely can happen. So, yeah, I wonder if we actually want to do it like that with removing. Maybe what I should do is look at, like, where do we call? What it would probably be is like dot remove. That might not. Game events. Here we remove the listener. Okay, that actually worked out pretty well. So here's a bunch of places that we are removing these events. So it does happen. It definitely happens. Okay, so maybe I need to do that. So what would be the ID? I guess if we wanted to do it that way, we just need to have some ID that is incremented. So we'd have like a UN32 ID, and then maybe up here we would have, actually no, we would want to put it inside of here. We'd keep it so it's private though. So we'd say we would have, maybe we do it like this. Do we need to really expose the callback? Maybe we would want to have it like this. This feels weird, splitting it up into two chunks. Feels weird. We don't need to do it like that. What am I doing? I was just thinking like, wait, where are we even putting this? We could just put it down here, right? Where would it be? The like callback data, which would just have a callback, and then the ID. Yeah. I don't really think we need UN32 for that. I guess it doesn't really hurt anything. Okay, so with that, then we would just say, okay, this is callback data instead of callbacks. And so whenever we are adding it, what we'd actually want to do is we could call in place back. Oh wait, no, we can't. That's right, we don't have. We would just say this is like ID plus plus. That's one nice thing about having this be a UN32. We don't have to worry about it ever rolling over, right? I don't think so. We have millions of IDs, so it's like we're never going to run out of IDs here. Let's increment it afterwards, right? Yeah, and then maybe what we'd do is we'd initialize it to 1. And so 0 would just be an invalid. So then we could return a UN32, which could be the that. And if we really want to do, we could say, hey, using callback handle is a UN32. So then we could just do that. I don't know if that's actually like a good thing, but then we could say, hey, this is a callback handle. And then in here, template, type name, t, void, event, remove. Maybe we would want to have remove return a value, which is if it successfully removed it or not. I don't know if we actually need that, but we can. Doesn't really hurt anything. And what I would just do is iterate through all of these for auto callback, or yeah, callback is fine. Callbacks. If, and we can make it const. If callback the ID is equal to the handle, then we want to return true. Oh, whoops, sorry. Oh, we want to remove it, duh. I need to, yeah, I guess we should do it this way. If, iter ID is equal to the handle, then what we want to do is erase and then return true. Otherwise, I guess we can increment here since we're going to be doing that. So we'd want to, we don't care about updating the iterator, so that's fine. You can say erase it and then return true. And then here we would return false. So this is if we found it or not. We'll get padded if it's smaller anyways. Oh, okay. Yeah, true. Cool. So that's something I never really thought about, is like the whole padding thing. Need to keep that in mind. So yeah, that's a pretty basic little event class. What's wrong with this? Should be fine, right? Siege. What am I missing there? Oh, right. Okay. I was messing that up. I was like, I think I might be forgetting something, which is that this needs to be ... t, right? I think so. Got those flipped around. Right. That's something I'm still getting used to. Okay. Okay. Callback. Now we need to say this is a callback handle. And we need to, oh, actually, that's a good point. That maybe what we should do is use the ID and then return the ID plus plus. There we go. Padding. Pad with the D, padding. What's up, Cooler? How's it going? Callback handle is undefined. Oh, yes. Let's actually put that up here. So that way people don't have to do like event callback or whatever. Like, yeah, it should be here. Cool. So that's good. Yeah, it looks pretty good. Really simple, actually. One thing we could do whenever we clear, if we really wanted to, is reset ID to 1. Not a big deal, but I don't know. Actually, do we want to do that? Maybe we don't need to. I'm like, so the thing about that is then if we try to, the nice thing about not resetting the ID back to 1 is that means that if we have any handles that are still out there, they are just invalid. Whereas, like, let's say that you have a handle and then we clear it, and then later it's like, oh, actually, I want to remove this, and then suddenly now we're removing some other callback or something like that. Whereas if we don't reset the ID, then that means that every single callback that registers itself with this event will always be given a unique handle. I think that's important. Yeah, and we have like millions of possible handles, and yeah, for Korea we probably would never pass more than like a few hundred, and that's for like the more popular callbacks. There's most callbacks that are set up that don't ever have something removed, like the door that's being interacted with. We set that stuff up at runtime, and it's pretty much just static, where it's like, oh yeah, it's going to call these two functions, period. And we're not like dynamically adding and removing listeners to that event. Yeah, so that's awesome. Good stuff. I think I'm going to call a stream there. That's a good stopping point. I think tomorrow we'll pick this back up and maybe work on the event some more. Maybe we'll look at that whole like hashing with the string literals. I think that might be a good thing to finally do. So then we could have like a event map if we wanted. And I'll do some more research on this and see if we can come up with something else. Yeah, sorry, it's like 4:30 now. I need to do dinner soon and everything. But yeah, thank you all for joining. I really appreciate it. I hope you all have a good rest of your day. I'll be back tomorrow afternoon, 1 p.m. Pacific time. We'll pick this back up. You're welcome to watch, VODs here if you missed anything, or on YouTube. I'll have stuff uploaded tomorrow. GGGS. All right, guys. Have a good one. Take care. See you tomorrow.